Alright, well, welcome to Algebra 2 Test 5 review. This is the Rational Expressions test. If you're here to redo the test, appreciate you being here, putting in the time to raise your grade. Again, this isn't punishment. You didn't do anything wrong. We're just trying to help you raise your grade by redoing this test that maybe you didn't score too well on. So we're going to go through 10 problems, just kind of let you know the setup on this is that as you hopefully should be familiar with, on the left side I'll do the problem to kind of remind you how to do it, and then the problem in the middle and then the problem that's on the right side I'll have you do those for practice. The one in the middle, I'll give you the answer for it. If you get it right, then you can fast forward and try the one on the right. If you get it wrong, then you can watch the explanation of it. And then the one on the far right, I'll give you the answer for that one, but I will not work it out, nor will I explain it. So that's where we want to make sure that you're kind of on your own at that point and that you're able to do it. And if you're not, that's okay, just ask a question. Alright, so let's start by putting your name on your paper. And if you are coming from a different teacher, if you just would put your teacher's name. Most of you may be my students, but for some that might be coming from a different Algebra 2 teacher, then just put your teacher's name on there so we make sure we get the paper going to the right place. Alright, well, so what this test covers, just kind of give a general idea of what this test is going to cover, really looking at rules of exponents and how they apply in using rational expressions. And we'll kind of define in a second what exactly a rational expression means. But I want to kind of take you back real quick before we get started. Take you back to kind of middle school for a second, just to kind of think about basic ideas of exponents. And what I'd like you to do on the top left part of your page is, you've seen I've written down multiply, coefficients, add exponents. What I'm going to do is, just like please excuse my dear Aunt Sally is a way to remember the order of operations, I've got a little thing here for you to remember, MADSPM, or MADSPM, if you want, however way you want to think of it. And what it does is it helps us have a little memory trick to remember the rules of exponents, because what's tricky about exponents, sometimes you add them, sometimes you subtract them, sometimes you multiply them. And then so it can be kind of confusing to remember when you do which. So this is a little tool that will help us remember that. Now, before we do shortcuts, I always kind of like to think of things, doing it kind of the long way first. For instance, if I wanted to multiply x squared times x cubed, now there's a shortcut for this, but we're going to do it the long way first to kind of discover the shortcut. Well, x squared would be x times x, and then x cubed. Actually, let me do this in a different color so you see the difference. And then x cubed would be x times x times x. And then so what I would say is, well, how many x's do I have? Well, I've got 1, 2, 3, 4, 5. So that means that this answer would be x to the 5th. And then what I look at is I say, okay, it was 2 and a 3, and the answer ended up being 5. Oh, okay, well, so the shortcut is that if I'm multiplying, then I'm going to add the exponent. So that's what the M and A stand for, is that if you're multiplying, you're going to add the exponents. Now, let's talk about if you were dividing. So if you were going to divide, what you would have on that is that, let's say we were doing, I don't know, let's do x to the 5th divided by x squared. Okay, so again, if I was gonna write this out, I would say x times x times x times x times x, right? Because I got 5 of them, 1, 2, 3, 4, 5, over x squared, which would be x times x. And what I'm looking for is I'm looking for things to cancel, and then whatever's left over would be my answer. Well, it looks like there's 1, 2, 3 x's left over, so my answer would be x cubed. So what I do is I then look at the relationship. What's happening here? 5 and 2, then the answer was 3. Oh, okay, so what it looks like what's happening there is that when I subtract, right, when I divide, I'm going to subtract the exponent. So that's the shortcut for that one. So that's the D and S part of it. And then the last part of this, and again, we're just mentioning this, so before we get into number 1, because you look at number 1 there, and there's all kinds of exponents, we're going to actually have to use all 3 of these exponent rules. So I'm wanting to start off with just kind of the basics with you real quick before we dive into the Algebra 2 part of it. All right, last rule here, the P and the M says that when you have a power to a power, you're going to multiply those exponents. And an example of what that might look like is that if you had, let's say, x cubed, and then that was to the second power. So you notice there's an exponent on top of an exponent. Well, what x cubed means is x cubed squared means x cubed times x cubed. Right? The 2 just means take whatever the base is and do it twice. So x cubed is the base, so I'd write x cubed out twice. Well, we could do 3 plus 3 by the first rule, so it would be x to the 6th. However, if I wanted to write all this out, x times x times x times x times x, 1, 2, 3, 4, 5, 6, right? So I've got, move that out of the way. So I've got 6 of them, so then what I would say is that the answer would be x to the 6th. And then what I do is I look back and I say, well, surely there was a shortcut to that, so I didn't have to do all that. And then what I notice is that 2 times 3, if I just multiply the exponents, that would give me my answer. Okay. So we're going to refer back to this, the MATSPM or MAT-SPM. When you multiply, you add the exponents. When you divide, you subtract them. And when you have a power to a power, or another way to think of the P is that if you have parentheses, you almost kind of think of it as distributing. So that's when we're going to multiply the exponents. All right, well, that's really important that we understand the basic rules of exponents, because we're going to encounter and see those throughout this entire review and on the test itself. So it's really important that we have the basics down first before we move on. Now at this point, let's go ahead and move on. So let's take a look at the first problem. Now actually, you don't, on this what you see in front of you here, this is actually not on your piece of paper. You don't necessarily need to write this down. I'm just kind of setting the stage for us here. You'll notice rational expression, and I do want you to write that down at the top of your page. What's a rational expression? Well, I kind of refer to it as a funky fraction, and what we mean by a funky fraction is that it's just a fraction with numbers, variables, and exponents. So what we're doing on this study guide and on this test is we're really just reducing fractions. We're going to multiply some fractions, divide some fractions, and add some fractions. But you know, when you think of a fraction, you probably think of something like this. You probably think of something like 2 over 3. Well, that is a fraction. It's just a baby fraction, right? So those are the kinds of fractions that you encountered or that you saw in elementary school and middle school. This guy right here, 2x squared plus 9x plus 9, is a fraction as well. It's just kind of a funky fraction. So anytime you got a bar, that bar right there means it's a fraction. So it's just got more things in it. It's got numbers, variables, and exponents. Right, because we said numbers, variables, and exponents. So that's what makes the difference there, is they're both fractions. Both of these things are fractions here. It's just that one of them's got numbers and variables and exponents. And we're going to refer back to this because how you add, subtract, multiply, divide baby fractions is going to be really the same way that you're going to add, subtract, multiply, and divide these funky fractions. So we'll keep referring back to this. All right, so let's go ahead and take a look at the first one. And what we have here is that we're going to use actually 3 of our exponent rules in this one problem. Now, what we want to do first, and it's almost kind of, if you think about, again, go back to that, please excuse my dear Aunt Sally, we do parentheses first. So what we want to do first is that we're actually going to do our parentheses where we're going to multiply first. So our first thing that we're going to do is actually the P and M part, which is the power to a power. What that means is that I'm going to take the number that's on the outside of the parentheses and I'm going to distribute it to everything that's on the inside. Now if you look at it, there's no number right there. Well, if there's no number, everything really has an exponent. If you don't see it, it's really that it's a 1. And that would be the same thing on the bottom here as well. So what I'm going to do is I'm going to take that 4 and distribute it to everything that's on the inside. So I'll distribute there, there, and there. Now I'm not going to distribute over here because that parentheses doesn't have an exponent on it, right? So the 4 is only on that group right there. And then the 2, again, I'm going to do the same thing, is distribute this across as well. And I really would encourage you, by the way, to draw those arrows to make sure, draw those ones in so that you make sure that you don't make the mistake and forget that they're there, because they really are there. Alright, so what I'm going to do is I'm just going to kind of recopy the problem here. The first group was the same, 4x squared yz. And then what I have for the second group there, 4 times 1, so that would be x to the 4th. 4 times 3, so that would be y to the 12th. And then 4 times 1, that would be z to the 4th. If I look at the bottom, now this says 2 times 1, which would be 2 squared, which would be 4. But I don't want you to think that what I did is I did 2 times 2. That's not what I did. I said 2 times 1, which would be 2 squared. 2 squared is 4. So that, because they end up being the same answer, that can be a little confusing. 2 times 2 would give us x to the 4th. 2 times 1 would give us y squared. And then 2 times 1 would give us z squared. And then now what we're doing is that we want to simplify. You can see on the top how we have kind of two different sets of parentheses here. So what we want to do is we want to combine those two things together. Well, you know that when parentheses next to each other like that, that means that you're going to multiply. So then that's going to be our next step, is that when you multiply, you're going to add the exponents. So I'm going to multiply the numbers, and I'm just going to add the exponents. And so what you'd have on the top, now 4, there's no other numbers to multiply 4 with, so I just would have 4. And then I have x2 and x4. And I'm just going to kind of color code this so you see where these numbers are coming from. So I'm going to say x2 and x4 to get x6. And then I'm going to add the y's. There's really y to the 1st. And then I've got y12. So if I say 1 plus 12, that gives me 13. So that would be y to the 13th power. And then let's talk about the z's. So with the z's, that would be z to the 1st. That is z to the 4th. So I'm going to add 1 plus 4 to get 5. So that would be z to the 5th power. And then what was on the bottom, I left that the same. So I've got x4, y2, and then z2. And what we do with this is we kind of treat this like a game where we make one move per turn. We don't try to do the whole problem all at once. So we just do this kind of in parts. And now that we got to the final piece of this, which is that when we divide, we're going to subtract the exponents. So the last part of that is that when you divide, you're going to subtract the exponents. Now 4 divided by 4, those two things would cancel each other out. So the 4's would cancel each other out. And then what you would say with the x's is you would say, well, 6 minus 4, which would be 2. 13 minus 2, which would be 11. And then 5 minus 2, which would be 3. So for your final answer, you'd have x squared, y11, z cubed. Alright, well, so that was the first problem. So that was me showing you how to do it. Hopefully now you feel a little bit better about maybe how to do this. So go ahead and pause the video now. Try number 1 in the middle. And then when you think you have the answer, go ahead and press play again. And I'll show you what the answer is. And then you can check your answer. And then we can go from there. So go ahead and press pause now. Okay, so you should have completed number 1 in the middle. Let's go ahead and check what number 1 in the middle was. The answer was x cubed y to the 9th. Oh, wow, excuse me. X cubed y to the 9th and z cubed, right? So I'm filming this live, so you're catching the mistakes and all. So that's what you should have got for number 1 in the middle. If you got that, go ahead and pause now and try number 1 on the right side. If you did not get that as an answer, then hang on and we'll actually explain how to work the first one. Alright, so again, parentheses are first. And one of the things that I like to do first as well is that anything that doesn't have an exponent, I go ahead and write the exponent in there, which it would be a 1. So I'm basically just going through there and making sure everybody's got an exponent on it. And then what I'm looking for is I'm looking for the parentheses that I need to distribute. So I need to distribute 3 times 1 3 times 4, 3 times 2, and I need to distribute across here as well. Well, maybe we won't go underneath. Maybe that's a little more difficult to see. So I'm going to distribute here and going all the way across there, right? So I'm just distributing across. And so let's see what you'd come up with. Now again, the first parenthesis stays the same. Actually, let me go back to my other pen. First parenthesis stays the same, so I've got 9 to the first power, x cubed, y to the first power, z squared. And then in that second set of parentheses, 3 times 2, which would give me x to the 6th, 3 times 4, which would give me y to the 12th power, and then 3 times 1, which would give me z to the 3rd power. And now this is, again, so this is a good example where you see that this is not saying 2 times 3. What I'm saying is I'm saying 2 times 1, which would be 3 squared. And maybe we could even write it that way. Now you could go ahead and just write 9, right, because that's what 3 squared is, would be 9. But I want you to see that the 2 is not getting multiplied by the 3, the base. You're multiplying the exponents, 2 times 1. 2 times 3, which give you x6. 2 times 2, which give you y4. And then 2 times 1, which would give you z squared. All right, so let's combine what's on the top. So this is where we use our multiply. You're going to add the exponents, right? The first thing we did there was the power to a power. We multiplied the exponents. Now in this next step, what we're going to do is we're going to, when we multiply, add the exponents. And again, I'll do the same kind of color coding as we did last time, just so we can see where all this stuff is coming from, right? So you've got x3 and x6. Let me make that a little darker. There we go. So you got 9. Now 9 to the anything to the first power is just itself, so 9 to the first power would just be 9. You have x to the 9th power. And then let's talk about some y's. So if I took the y's, I've got y to the first power, y to the 12th power. So if I had 1 and then 12 more, now I've got 13. So that would be y to the 13th power. And let's look at our z's. So with our z's, I've got 2 right there, and I've got 3 right there to make a total of 5. So that would be z to the 5th power. And what's on the bottom? 3 squared, which would be 9. And then I got x6, y4, z2. Now, so let's go ahead and do some canceling here. So it looks like the 9s will cancel. And it's not always that these numbers are going to be exactly the same. It's just kind of how it ends up being on these two problems. Let's subtract. So 9 minus 6, which would be 3. And again, if you wanted to think of it, if you wrote out 9 x's and then wrote out 6 x's, 6 of those x's would cancel and 3 of them would be left over. So 13 minus 4, which would be y11. And then 5 minus 2, which would be z3. Right. All right, so hopefully you were able to, if you made a mistake on that somewhere, hopefully you were able to catch your mistake and come up with the right answer there. All right, so let's go ahead and pause the video now. And so hopefully we're trying to slowly release you. So it's kind of like training wheels. You know, the first problem is me showing you how to do it, and then we're slowly trying to take the training wheels off so you can ride the bike on your own. So hopefully by the time that you get to the problem that's on the right side, that third column, you're able to do these problems hopefully by yourself. So go ahead and try number 1 on the right side, and we'll check the answer here in a second. All right, actually before we move on though, I just noticed something. I think maybe that sneeze has got to my math brain a little bit. 13 minus 4 is not 11. We shall fix that. So if you're thinking, hey, I didn't get that, well, okay, so it's 13 minus 4, which would be 9. All right, so we fixed that little mistake there. All right, well, let's check number 1 on the right side, see what you came up with there. Should have got x to the 11th, y to the 1st, z to the 7th power. Right. So if you got that problem, great. We're going to go ahead and move on to the next problem. If you didn't get that problem, hopefully here's where some of the learning takes place. Try to figure out, you know what the answer is, so maybe try to figure out your mistake, figure out where you went wrong, and then if you're still having problems figuring it out, then go ahead and pause the video and I'll come over there and help you, right? So that's one of the reasons why you're doing this in the computer lab at school, so that you can pause the video and I'm still there physically in the room to help you. So that's going to be true for all of the third column problems on this study guide, is that if you're stuck, it's okay, just ask. Alright, let's go ahead and look at number 2. It looks kind of the same. Now, the only thing that looks a little bit different, you notice that there's some negative exponents, so we'll have to kind of explain maybe what that means. So let's look at what else is here. So we kind of started with the parentheses. That's what we started with last time. So it's going to be kind of starting with the same thing here. Is that we're looking for a power to a power. We're looking to see if we got some exponents to multiply. Now you notice on the top there's no parentheses, so there's nothing to multiply. The only place that you see where there's parentheses is on the bottom. So you would have to distribute on the bottom here. And we want to mark that there's an exponent there, right, an exponent there, so that's really x to the first. And then let's distribute this 2 out. So we're going to draw an arrow all the way across. And the reason behind drawing the arrow is just to make sure that you do multiply all the way across, that you don't forget to multiply anything. Alright, so you got 2x cubed, y to the negative 2, z squared. And then on the bottom, 3 to the first, which would be 3 squared. I wrote 3 squared. You could also, 3 squared is 9, kind of like in that last problem. So that's something you could have already went ahead and written as well. And then you've got y to the negative 2. And then you've got z to the 4th power. All right, so maybe a couple ways to look at this is that it's going to be the same idea of that when you divide, right, which is this second exponent rule, you subtract the exponents. So if I looked at it, and I think what I will do, just so we don't have to rewrite this whole thing again, 3 squared, we'll go ahead and write that as 9. So if you didn't write that as 9, let's go ahead and write that as 9. Now, there's nothing I can do to reduce, right? Nothing goes into 2 into 9. So that would stay the same. And then I'm subtracting. So x3, x2, so 3 minus 2, which would be x to the 1st power. Now what I'm looking at, though, is I'm trying to figure out, it's a fraction. So then I guess the question becomes, is that if I've got an x left over, right, because I've got an x left over, and then the question becomes, where's that x going to go? Is that x going to go, oh, come here for a second. There you are. Is that x going to go on the top, or is that x going to go on the bottom? Well, the way that you figure out where it goes is you ask yourself, well, what do you have more of? Do we have more x's on the top, or do we have more x's on the bottom? We have more x's on the top, so that's where that one leftover x would go. Now, anything divided by itself is 1, meaning that it just cancels. So y negative 2 divided by y negative 2 would just cancel. So those two things would cancel each other out. And then what you're left with, you've got 2 and 4. So if you subtract, 4 minus 2 is 2, right? So you've got a z squared, kind of same situation there. You got a z squared left over, and then the question becomes, okay, well, where's that going to go? Does that z squared go to the top with x, or does it go to the bottom? Well, again, ask yourself, where do you have more z's? Well, you've got more z's on the bottom, so the z squared would go on the bottom. And not that we would need to write it out this way, but just to so you get the visual on that. If we were to write that out, z squared would be z times z. Z to the 4th would be z times z times z. And the z's would cancel, and so where are the z's left over? Well, they're left over on the bottom, so that's why z squared ends up on the bottom. And we will talk more about negative exponents in a moment. I know I've got my turn that frown upside down. We'll talk a little bit more about negative exponents on one of the problems coming up. But for this particular problem, it's good enough for us to know that just anything divided by itself would cancel. All right, well, let's take a second and Try number 2 in the middle. See what you come up with. So go ahead and pause the video now. Alright, so let's check number 2 in the middle. So here's got f to the 7th power times g over 2 times h to the 11th power. So if you did get that as an answer, great. You can go ahead and fast forward. If you get this answer right, you don't have to sit through the explanation of me explaining it if you already know how to do it, right? So this is really, this next part of me explaining this particular problem is for those people that maybe didn't get that as an answer, right? Otherwise, if you did, go ahead and fast forward to the, or try, I should say, try number 2 on the right side, right? So, but if you didn't get it correct, let me go ahead and walk you through this particular problem. And by the way, I should say that if you didn't get this correct, you want to try to do as much of this as possible on your own. So, you know, if you didn't get this one right, but you figure out what your mistake was, don't finish watching me do the problem. Pause it, you do the rest of the problem, because you really want to try to do as much of this on your own, because, well, you're going to have to do that on the test. Alright, so, you know, same drill here. We want to be able to distribute the parentheses there. And I've got a 3 that I've got to distribute. So I'm going to multiply all of those by 3. So I'm going all the way across there. And then the number on the top stayed the same, so let me go ahead and write that. So we had 4 f to the negative 2, g to the 4th, h to the negative 5th. And here we got 2 to the 1st, which would be 2 cubed. Actually, a little pen malfunction here. Okay, there we are, we're good. F negative 3 times 3, which would become f negative 9. And g 3 times 1, which would be g3. And then 3 times 2, which would be h to the 6th power. Alright, so, you know, on that last one, the negative exponents that we encountered, they were actually the same numbers, and so we were able just to cancel them out. But you notice here, for instance, f negative 2 doesn't cancel with f negative 9, or h negative 5 doesn't cancel with h positive 6. So we're going to have to figure out what to do with that. So, you know, just as a kind of a quick reminder about what a negative exponent means, and I'm just going to kind of go to the side real quick and kind of show you something. I don't know, let's talk about what a positive exponent means. And you already kind of know what it means, but, you know, 2 cubed means 2 times 2 times 2, which would be 8. 2 squared means 2 times 2, which would be 4. 2 to the 1st power means, well, just 2. And this is a good proof as well as trying to figure out, well, what would anything to the 0 power be? Well, look at what's happening to the numbers. It goes from 8 to 4 to 2. So what's happening there? Well, the numbers are being divided by 2. So if the pattern were to continue, 8 divided by 4, or I'm sorry, 8 divided by 2, which would be 4, 4 divided by 2, which is 2, and then 2 divided by 2, which would be equal to 1. And then you notice the pattern on the exponents, 3, 2, 1, 0. And if I kept that going on that pattern, I would then have to keep the pattern going on this side. So what's 1 divided by 2? Well, it's 1/2. And if I kept going with the pattern to the negative 2, well, if I said 1/2 divided by half, that would be 1/4. And if I kept that same pattern, 1/4 divided by 2 would be 1 to the 8th power. Well, so notice the pattern here. 2 to the positive 3 is 8. 2 to the negative 3 is 1 over 8. 2 to the positive 2 is 4. 2 to the negative 2 is 1 over 4. 2 to the positive 1 is 2. 2 to the negative 1 is 1 over 2. So hopefully what you realize there is that what the negative exponent means is it just means that it's a fraction. Negative exponents make fractions. And it's really the same number as if it were positive. So, you know, if you wanted to know what 2 to the negative 4 is, well, what's 2 to the positive 4? Well, 2, 4, 8, 16. So 2 to the negative 4, if we kept going with this pattern, would be 1 over 16. So if you're wondering what that turn the frown upside down was, that's what we're saying. That's just a little kind of trick to remember it, which is that anything to a negative exponent is you turn the frown upside down. So upside down means reciprocal. Frown, right, when you turn a frown upside down, it turns into a smile. What we mean by frown here is the negative turns into a positive. So what that means for us over here is that we would have to take, and then 2 cubed, which would be 8. Now f negative 2, so what that means is that f negative 2, and I'll kind of color code this so you can see it, f negative 2 would go to the bottom if we turn his frown upside down and become f positive 2. Now if you notice g4, it's a positive exponent, so it just stays the same. So again, we're only doing these for negative exponents. So if you notice on the bottom there, f negative 9, well, that's a negative exponent, so that would have to go to the top. Actually, maybe we'll move this over so we can keep the f's on this kind of lined up with each other. So f negative 9, if we turned his frown upside down, that would become f positive 9. Now let's go ahead and squeeze in the g. And actually, the g on the bottom is actually also a positive exponent, so that would stay the same. h negative 5, need to turn his frown upside down. So again, turn the frown upside down just means take the reciprocal, and the negative exponent becomes a positive exponent. So that would come to the bottom and be h positive 5. And then the last one here would be h positive 6. All right, so now I think we're a little bit closer to be able to put everything all together. Now 4 divided by 8, that actually is a fraction that you can reduce. You can divide both of these by 2, right? You can divide that by 2, and you can divide the bottom by 2 as well. So let's divide those by 2. So that would be divided by 2, divided by 2, which hopefully you recognize, right? 4 over 8, that's just 1/2. So we've got 1/2. Let's talk about f's. 9 minus 2 would be 7. There's more f's on the top, so that would be f to the 7th. 4 minus 3 would be 1. There's more g's on the top, so that g to the first power would go to the top. Now you notice h5 and h6 are both on the bottom. This goes back to our, when you're multiplying, you're going to add the exponents, right? So that's what the M and A in our MATSFM says, is that if you're multiplying, you add the exponents. So if we added those two things together, that would become h11, right? Because 5 plus 6 would give us 11. So I'd have h to the 11th power. Now if we were to clean this up, you probably wouldn't see the 1, so what you'd probably see would be f to the 7 g. And then on the bottom, you'd have 2 times h to the 11th power. So again, on those negative exponents, you just have to turn the frown upside down. All right, so pause the video now and try number 2 on the right side. Let's check in with you. So number 2 on the right side, you should have 3a to the 5th, 8b cubed, c to the 5th. So again, if you got that one correct, great. Let's go ahead and move on to the next problem. If you didn't get it correct, hopefully you try to figure out your mistake. And if you're still not able to figure out the mistake, then go ahead and please ask for help. That's what we're here for. All right, so let's take a look at number 3. So now if you look at number 3, it looks a little bit different. You notice here that it's on the top you have a trinomial. Remember that a trinomial means a group of 3. 1, 2, 3, right? So these were, when we looked at quadratic equations, that's what that should look familiar. On the bottom you have a binomial there. You got 2 terms, x squared minus 9. Now that's a special case. It's a difference of squares, which again, hopefully that's something you should recognize. Now you probably notice the coat down there on the bottom. You'll notice the note there, polynomials, which polynomials, it just means groups. Groups must be factored before you can cancel. So what you can't do with this is that you can't say, oh, x squared and x squared, those things cancel. The reason why you can't do that is that this is a part of a group. So if it's a part of a group, things must be canceled as a group, right? So what you're going to have to do is we're going to have to factor this thing first. So what we're looking for is that if we factored the top and then we factored the bottom, then what we're hoping for is that if we have a group that's the same, that maybe we could cancel them, but we have to cancel them as groups, so it has to be factored first. So do not, let me erase that, so do not make that mistake. Now what does that have to do with Coke? I guess what the analogy there would be is that like a 12-pack of Coke, is that if it's packaged as a 12-pack of Coke, then you can't just rip in there and take one Coke out. You have to buy the whole 12-pack. And so my relation to that would be is that you can't just go in here and rip out an x squared and an x squared because they're a part of a group, right? So you have to be able to cancel them as a group. Don't think of them as individuals. Now, the last part of that is you wonder, well, how do I know that it's a group? Well, what makes something as a group is when you see the plus or minus sign. So the plus or minus sign is what kind of binds things together to say that it's part of a group. Also, another way to think of it is that a plus or minus sign is kind of like a comma in language, right, where you separate out a list of things. So 3x squared, comma, 7x, comma, 6. That's another way to think of that as a group. All right, so we know we have to factor, so we need to get things in our factors here. Hopefully by now we recognize x squared minus 9 as a difference of squares, and we can immediately go to that. And if you do recognize that, then you can go straight to the factors. But if you need a little refresher, then we can show that as well. All right, so this is doing the big X problems, right? So that's what these problems are doing. So let's take 3x squared, and I'm just going to kind of come over to the side over here and do a little bit of scratch work with this. So for 3x squared on the top, what I'm looking for is that I'm taking a times c. So here's my a, b, and c. So remember, what goes on the top is a times c, and then what goes on the bottom there is the b. Well, a times c would be 3 times negative 6, which would be a negative 18. And what goes on the bottom is the b, which would be a positive 7. And then what we're looking for is we're looking for two numbers that multiply to a negative 18 that add up to a positive 7. So you think about the ways to make 18. 6 and 3, but that wouldn't add up to 7. 9 and 2. Now, 9 times positive 2 is a positive 18. We need that to be a negative 18. So that means that one of these has to be negative. Then the question is, do I make the 9 negative? Do I make the 2 negative? Well, you look at what you have more of. You have more positives on the bottom. So if you have more positives left over, that must mean that the bigger number was positive to begin with. So that means that the smaller number would be negative. And you could check that, because if you said 9 minus 2, well, okay, there you go, it's 7. All right, so now we put those in parentheses. So x plus 9, and then x minus 2. And then there was one other step with this, is that you had to divide by a, whatever the a is. In this case, the a is equal to 3. So you have to divide both of those by 3. And when you do that, you get x plus 3. And if you remember from quadratics, we talked about if you can't divide it, slide it. That's right. You didn't see me, but I slid across the floor. That's my little dance move. So yeah, you're going to slide the 3 in front of the x, and so we get 3x minus 2. So again, this was all of this that I did over here was just my scratch work to come up with this, which would be x plus 3 times 3x minus 2. By the way, how can I check to see if this is correct or not? Well, multiply it out, right? X times 3x is 3x squared. 3 times negative 2, negative 6, right? And then negative 2x plus 9x would give you 7x. That's one way that you could check that. All right, then for the bottom, and hopefully, like we said for the bottom, hopefully you recognize that as a difference of squares, and you know the pattern on that one. It's the square root of that number. One is a plus, one is a minus. So you'd get x plus 3 and x minus 3. If you weren't sure, however, if you felt like you needed to do the big X on that one, you know, your negative 9 on top, 0 on the bottom. So two numbers that multiply to negative 9 that add up to 0 would be positive 3 and negative 3. When you divide by a on this one, the a is 1, so that's how the numbers end up staying the same. The a was bigger than 1 there, so that's why we had to do the divided slide it. Now the last part of this is you're looking to cancel. So again, It's a package deal. You have to cancel them as groups, not as individuals, but as groups. So what I see is there's a group of x plus 3 and a group of x plus 3 that are the same. So I can cancel those. And then if I see what's left over would be, I'm just going to come underneath here, 3x minus 2 over x minus 3. And you notice I left the parentheses off. You can, leave them on there, leave them off. It doesn't make a difference. It ends up being the same thing. All right, well, same routine here. Go ahead and pause the video and try number 3 on the right side. And again, try to do as much of this on your own as possible. If you get number 3 in the middle wrong and you have to watch me explain a little bit of it, don't just watch me do the whole thing. Maybe pause when you get yourself unstuck and see if you can figure it out from there. All right, so number 3 on the middle, all you. All right, so let's see what you got with number 3 in the middle. Should have got 3x plus 1 over x minus 5. If you did get that one correct, great. Go ahead and pause it now and try number 3 on the right side. If you didn't get that one right, then let's take a look at the explanation on that one. So again, we're dealing with groups here, and we said that just like our 12-pack of Coke, we can't go in there and rip one of them out. So in that same way, I can't just start canceling. I can't say, oh, 5 goes into 25 5 times. I can't start doing that. Cannot start doing that because it's a group. So I must factor first, and I'll give you another way to kind of set up the work if just maybe another way to organize it, I suppose, is that on the top there's your A, B, and your C. So we're looking for two numbers that multiply to 15, and we want those same two numbers to add up to 16. Alright, so you think about what multiplies to 15. You got 1 and 15. Oh, 1 and 15, right? Because that 1 plus 15 is 16. You might have thought 3 and 5, but that doesn't add up to 16. So yeah, we'll say 1 and 15. And then another way that you could show the work on this one, instead of having to rewrite out the parentheses, is that you're going to divide by a, which in this case is 3. So you can divide right here inside the big X. This is just kind of a shortcut so that you don't have to rewrite the parentheses out again. So what you would do with this is you'd say, okay, well, 1 divided by 3, that doesn't divide evenly, so I'm going to have to slide it. So what that would become is it would become 3x plus 1. 15 divided by 3, that does divide evenly, so that would be x plus 5. And then on the bottom, you've got x squared minus 25. Again, at the Algebra 2 level, you really should be recognizing differences of squares. Again, that's when you have two terms that are being subtracted that are both perfect squares, and the factors are just the square root of that number. One is a plus, one is a minus. However, if you needed to see that by using the big X, we could certainly do that as well. Here's your A times C and B. By the way, your A here is really 1. There's your C. And the B is missing, so that's why the B is equal to 0. So two numbers that multiply to negative 25 that add up to 0, of course, will be plus 5 minus 5. Now what we're looking for is we're looking to see what will cancel. I see a group of x plus 5 cancel with a group of x plus 5. And yeah, that's it. Now what I can't, here's another thing I can't do, and this goes back to the 12-pack of Coke over there. I can't do this. I can't say, oh, I'm going to cancel the x and the x. Well, no, you just broke into a group, and these two groups don't match, so you can't do that, right? So that's what I mean about that idea of you can't break in there and just take one out. You have to be able to, it's a package deal. You got to be able to buy the whole thing. So what's left over there will be your answer. So what's left over on top would be 3x plus 1. What's left over on the bottom would be x minus 5. All right. Well, try number 3 on the right side. Go ahead and pause now. And when you feel like you got the answer, go ahead and hit play, and we'll check the answer. All right, so let's see what you got for number 3 on the right side. Should have got 3x minus 4 over x minus 2. So again, same deal. If you got it right, let's move on. If you didn't get it right, try to figure it out first on your own. Then if not, ask for help. Alright, so now before we go on to the next one, I want to kind of set up the next couple of problems. Again, when referring back to this definition of a rational expression just as a funky fraction, a fraction that has numbers, variables, and exponents. The next couple problems involve multiplying rational expressions. Well, before we try to start multiplying something that looks like this, let's just even remind ourselves, how do you multiply baby fractions? Well, so one thing that you can do is that you can cross-cancel. And so what we do with that is that you'd say, okay, well, 2 goes into 10 5 times, right? And 3 goes into 9 3 times. And then whatever's left over would be your answer. Well, what's left over there would be 3 over 5. That would be your answer. Now, the longer way of doing it is just multiplying straight across the top and straight across the bottom. So if you did that, you'd have 18 over 30, and then you'd have to reduce, right? So you'd have to divide top and bottom by 6 here. Say divided by 6, divided by 6. And then so you'd end up with the same answer, but I would argue, and hopefully you would see, that that ends up being a little bit more work. So it's much easier to do it this way right here, which is you cross-cancel first. It's almost like you're reducing first and then multiplying. This first, what's on top here, this is multiplying then reducing. Well, it's much easier to cross-cancel first. So that's how you multiply a baby fraction. So what are we going to do with the funky fraction? We're going to do exactly the same thing. We're going to cross-cancel. It's just going to look a little bit different because there's x's and y's, but it's really going to be exactly the same idea. Alright, and by the way, I'm doing this slightly out of order. I'm doing number 5 next, and then I'm going to come back and do number 4. And the reason why I'm doing this is that number 5 on this review, this is really number 4 on the test, so the problems got switched here. So, but we'll do number 4 next. Alright, so no plus or minus sign. So you see the 12-pack of Coke is gone. So now you just got a single Coke up here. Well, the reason why the single Coke is there is because, well, there's no plus or minus sign, so that tells you there's no groups. So if there's no groups, then you don't have to factor. You can start cross-canceling right away. Now, I say right away, but what we do have one thing to do, and you see that our MADSPM is back, is that if you have power to a power, you have to multiply those exponents first. Right, so you see I've got an exponent there and an exponent there. So I've got some distributing to do first before I can multiply, or before rather we can start cross-canceling. So let's distribute. So I've got 2 times 2, 2 times 1, 2 times 1, 2 times 2, and 1 times 2. So let's just go ahead and rewrite that, what that would be with the new powers there, now that we've distributed. So that really what that ends up being is it ends up being 3 squared. So we don't have to write 3 to the second power. We can go ahead and do that mentally. So that just would be 3 squared, which would be 9. The bottom, you notice there's no parentheses on the bottom, so the bottom just stayed the same. Nothing happened there. And then on the top, so 2 times 1, which would give you 6 squared. So 6 squared would be 36. 2 times 1 would be 2. 2 times 2 would be 4. On the bottom, again, no parentheses, so nothing to distribute. And again, now, no plus or minus sign, right? So it's just our singles here. So we can just start slashing away here. We can start cross-canceling. It doesn't matter where you start, just, I don't know, whatever sticks out to you. I don't know, what I see first is maybe if I took 4 C's away from 5 C's, what would be left over would be just 1 C. And because there's more C's on the bottom, that's where that 1 C would go. If I looked at, I'm going to try to color coordinate, because I will warn you here that what can be difficult about this is you're doing a lot of slashing, and then it's kind of hard to see what's left over. B squared would cancel with B squared. And then let's talk about the numbers there. 12 goes into 36 3 times. So, and again, I'm just writing the leftovers above there. Let's talk about this direction. So if I wanted to cancel this way, well, a to the 4th cancels a to the 4th, and nothing left over, right, because they're the same. And then there aren't any b's. You see, that's the only b, so that b is going to stay the same. And now 9 doesn't go into 21, but there's a number that goes into both of them, right, which would be 3. So we want to divide both of those by 3. So if I divided 9 divided by 3, I'd have 3. If I divided 21 by 3, I would have 7. So I tried to write neat so that you and I could both see what's left over here. So it looks like what I have left over, and then sometimes I'll do this even with my highlighter. Say, okay, what I've got left over, I've got a 3 left over, a 3, I've got a C, I've got a 7, and I've got a B. That's just so it kind of sticks out so I can see it clearly. So what you got on top, 3 times 3, which would be 9, and then on the bottom, we've got B, C, and then I've got a 7 there, right? And what I almost wrote there, you almost saw me write that. Not that that's wrong, but kind of the formal way that we write it is that we always write the numbers first, the coefficient. So we'd write 7 first, and then whatever letters are there, write that in alphabetical order. So we'd say 7BC. But if you wrote it in a different order, that wouldn't be wrong. That's just most likely how you would see it. All right, pause now. Try number 5 in the middle. Welcome back. Let's see what you got for number 5. Number 5 in the middle should have got 10x cubed over 9 times y to the 9th times z. So if you did get that correct, go ahead and pause now. Try number 5 on the right side. If you didn't get it correct, hold on for the explanation here, and hopefully we'll try to figure out maybe where things went wrong for you. So we know that the answer should be 10x cubed over 9y to the 9th times z, so let's get that out of there, and let's just kind of start fresh here. All right, so again, first thing I'm doing is I'm just putting in my exponents, right? So that's really 5 to the first power, 4 to the first power, y to the first, and then z to the first. And then I've got to distribute, right? So that's my rule over here, that when I have a power to a power, that I'm going to multiply. So I need to multiply. So we'll distribute that. And as I've mentioned before, really do draw the arrows. I think it's a good way to help you not make any mistakes with that. All right, so let's see what you'd have left over once you did that. Again, that's not 2 times 5, so don't put 10. That's really 5 squared, which would be 25. 2 times 3, which would be x to the 6th. Let's look at the bottom. Again, there was nothing that we distributed there on the bottom, so that's just going to stay the same. That's not an x, that's a y. So y to the 4th, z cubed. And let's take a look at that other fraction. So on the top there, 4, and again, that's not 2 times 4. That's 4 squared, which would be 16. 2 times 1, which would be y squared. 2 times 1, which would be z squared. And bottoms didn't change. All right, and again, I'm going to try to color code this for you just so you can follow, where we're canceling from. And again, it doesn't matter where you start from. Just pick somewhere. Let's see, 25 doesn't go into 45, but 5 goes into both of them. So 25 divided by 5 would be 5. And then 45 divided by 5 would be not 5, but would be 9. Let's talk about some x's. So if I took 3 away from 6, what would be left over? Well, there would be 3 of them left over. So what you have left over there would be x cubed. And I try to write that above it so it's kind of clear to see. No y's over here, so y7 will stay the same for the moment. Let's talk about this other direction here. So 8 goes into 16 2 times. Let's talk about y's. You're always taking the smaller from the larger, right? So if you took 2 y's, away from 4 of them, which you have left over, would be y squared. And then let's talk about the z's. So if I took 2 away from 3, what would be left over would be 1. You don't have to write z to the first. You could if you wanted to, but you could also write just z. Either way, same thing. And then let's see what you got left over there. And I'll go back through here and I'll highlight real quick. So I've got a 5, I've got an x cubed, a 2. On the bottom I've got a y squared, z to the first, a 9, and a y to the 7th power. So let me write that. So 5 times 2, right, because remember, whatever's left over, you're just multiplying straight across. So 5 times 2 would give you a 10. And then you got an x cubed. See, on the bottom, 9 is the only coefficient or only number. And then you got a y2 and you got a y7. Oh, okay. Well, when I'm multiplying, and again, we'll refer back to our MATSPM over here. When you multiply, you're adding the exponents, right? So what we need to do there is that we need to say, and maybe we'll even kind of write that with this, we've got y2 and we've got y7, so we need to add those two things together. So that would become y to the 9th power. And then we got z left over, so we'll just write z. All right, go ahead and pause now. Try number 5 on the right side. Hopefully you're feeling pretty good about this at this point. Welcome back. Let's check your next answer. So for number 5 over there on the right side, should have got 7f to the 6th power over 20g squared. And again, if you got it right, great. If you did not, try to figure it out or ask for some help. All right, so let's go back. I told you we'd go back now. So let's go back to number 4. The reason why I wanted to do number 5 first and then number 4 is I wanted to do the multiplying or the fraction where you had your single coke there. You didn't have any groups, right? Because you didn't see any plus or minus signs, so we could start slashing away right away. I wanted to come back to number 4 because number 4 does have the groups. You do see the plus or minus signs. So what that means is that you cannot start doing this. You can't start saying, oh, 3 goes into 9 3 times. Can't start doing that. Cannot do that. Again, there's your 12-pack of Coke over here, is that it's a group. So if it's a group, you have to factor it first before you can do any canceling. So again, polynomials, right, because you got a binomial, trinomial, right? So polynomials must be factored before you can cancel. Well, so let's talk about factoring some of this stuff here. And I'm just going to write below it. Well, let's start with x squared plus 4x. You're like, wait, is that a big X problem? Well, no. Big X problems are when you have 3 terms, trinomials, 1, 2, 3. The one exception to that, and the one and only exception to that, is a difference of squares, where you have something that's a perfect square. But this is not a difference of squares. But what you do always have to check for is you have to check for a greatest common factor. So you have to see what they both have the same. Well, they both have an x, right? Because see, there's an x and there's an x. So we can factor out an x. And if you factored out an x and you said, well, x times what would give you x squared? Well, that would be x times x. And then x times what would give you 4x? Well, that would have to be 4. On the bottom, you notice that x plus 3, there's nothing you can do with that, so you just would leave it as x plus 3. Because there's no greatest common factor, they don't have anything in common, so you just would leave it that way. X squared minus 9, again, hopefully you're picking up pretty quickly. That's a difference of squares. It's the square root of the last number, just one is a plus, one is a minus. Now on the bottom there, 1, 2, 3, that is a trinomial. And, you know, you can start doing some of these mentally as well. What you're looking for is you're looking for 2 numbers that multiply to a negative 12 that add up to a positive 1. Well, what that would be, what multiplies the negative 12 that adds up to 1? Well, not 6 and 2. Oh, 4 and 3. Right? So you're thinking, oh, okay, so it's probably, 4 and 3. Then the only thing you got to decide is, which one's plus and which one's minus. Well, you have more positives left over. That's a positive one. So that means the bigger number would have to be positive, the smaller number negative. Now, again, you don't have to be there at this point doing that mentally, so I'm not trying to push you off the training wheels just yet. Don't want you to fall and skin up your knee. So if you still need to or still want to set up your big X over here, that is perfectly okay. Right? So now we can start canceling. Now, because now it's factored, right? So we can talk about some groups. I got a group of x plus 3, a group of x plus 3. I've got a group of x minus 3, a group of x minus 3. I've got a group of x plus 4, and I got a group of x plus 4. Oh, wow, looks like everything's gone. Oh, but not everything. Right? Because what do you got left there? You got an x left over. So the sole survivor here is just x. So I know that looks kind of strange that all of that would simplify down to just x, but that's what it is. All right, so try number 4 in the middle. Go ahead and pause the video now. All right, so I'm trusting that you've done number 4 at this point in the middle. Let's check the answer. So for number 4 in the middle, should have got 3 over x minus 2. If you got that one right, good for you. High five. Go on to the next problem, so you can go ahead and pause the video now. If you didn't get that as your answer, then hold on, and we'll try to come to the rescue here. So let's take a look at the top fraction there. So again, you're checking for a greatest common factor. So you're looking to see, well, what do these two things have in common? Oh, okay, well, there's a 3 that goes into both of those. And then what you're asking yourself is you're saying, okay, well, 3 times what would give me 6x? Well, that would have to be a 2x. 3 times what would give me 3? Well, that would have to be a 1. And if you're not sure, you want to check your answer, well, multiply. 3 times 2x, 6x. 3 times 1 gives you 3. Right? So you just check your answer on that. If you look at the bottom, that's 1, 2, 3. It's a trinomial. That means it's a group. So that means I can factor that using the big X. So let's see. If I wanted to, and again, I can do a little scratch work too. Maybe I'll just come down here to the bottom. 2 numbers that multiply to a positive 4 that add up to negative 4. Let's see. 2 and 2? Well, and it's a negative 4. Right, so that means it'd have to be negative 2 and negative 2. So on the bottom there, I'd have x minus 2. Right, x minus 2 and x minus 2. Let's look at the top. Difference of squares. Yeah, right, because you got 2 terms that are being subtracted. Perfect square. So square root of 4 is 2. 1 is a plus, 1 is a minus. So x plus 2 and x minus 2. Again, if you wanted to, you could show the big X on that. Not that you'd have to. And actually, to tell you the truth, I'd rather recognize that that's a difference of squares. So, because like I said, at this point, we should be able to recognize difference of squares. So yeah, this one would be x plus 2, x minus 2. And so you got this last one over here. So again, we'll kind of go to the side and do some scratch work on this one. So we'll put that one right here. Just need to figure out what it is. So let's see. Come over here, do some scratch work. So you're looking for, remember, it's a times c, right? A, B, C. So a times c, which would be 4, 5 on the bottom. And you're looking for 2 numbers that multiply the top that add up to the bottom. Well, not 2 and 2, because that didn't add up to 5. 1 and 4. And we always forget. I think we forget 1 in the number we're looking for. So you can't forget about 1. All right, so you can divide by a, which is 2. Just like we showed you on the other one, you can show that divided by a part and, save a little space here. You could show it this way. Divide by 2, divide by 2. And so because that doesn't divide evenly, if I can't divide it, I slide it. So that's where that would be 2x plus 1. And then 4 divided by 2, well, that's 2. Now we just want to take a look and see what we can cancel. Doesn't matter where you start. 2x plus 1, 2x plus 1. Let's see, x minus 2, x minus 2. I've got an x plus 2 and an x plus 2. And I should note there, by the way, I know we've been saying cross-cancel a lot. You cross-cancel, but what you can also do is you can also cancel vertically. The only thing you cannot do is cancel something next to each other, because that's multiplication. But if they're on opposite sides of the bar, whether they're diagonal from one another or on top of one another, you can do that canceling there. And so let me highlight what's left over there. Looks like I've got a 3 left over, and I've got an x minus 2 left over. So that would give me 3 over x minus 2. All right, so go ahead and pause and try number 4 if you hadn't already tried number 4 on the right side. Let's see what you got. Number 4 on the right side. 2 ways this answer could have been written, because you actually, when you work this one out, you actually get 2 groups left over on the bottom, 2 things left over that don't cancel. So you could leave your answer as 8x over x plus 4 times x plus 5, or you could multiply those 2 groups together, x plus 4 and x plus 5, to get x squared plus 9x plus 20. So if you FOILed that out, or if you multiplied that out, I'll show you real quick what I mean by that. Right, like if you multiply it out, x plus 4 and x plus 5, you get x squared plus 4x plus 5x plus 20, which gives you x squared plus 9x plus 20. So that's where we're getting that from. You could leave it either way. It doesn't really make a difference to me. And to tell you the truth, I've seen it written both ways. I've seen it written that way, seen it that way. So it doesn't really make a difference. Just know that it means the same thing. All right, well, hey, halfway there. Let's flip on over to the back side. Take a look at number 6. Now, number 6, and actually 6 and 7, deal with dividing fractions. So let's think about what we've done here. We've reduced fractions, these funky fractions, right? These fractions with numbers, variables, and exponents. So we've reduced funky fractions, we've multiplied funky fractions. Now we're going to divide some funky fractions, right? So divide, something that looks like that. Well, let's start first of all and just remind ourselves, how do you even divide a baby fraction? So something that looks like this. Well, what you do is that there's a couple different ways you can remember this. Some people remember it by saying copy dot flip. And what it means is that the first fraction stays the same. So that's why we say copy. Dot means that the division turns into multiplication. And flip means that the second fraction flips over. You take the reciprocal of it. So 3 over 4 would turn into 4 over 3. Once you've rewritten it as a multiplication problem, then it becomes exactly like what we've just done. You cross cancel, and then there's your answer. So that's going to be the same thing for us with these funky fractions, is that we're going to rewrite it as multiplication, and then we're just going to start doing some cross canceling. But we're going to rewrite it first. You notice I rewrote it first from division to multiplication, and then I cross-canceled. What I did not do is I didn't try to start canceling back here. So we're going to rewrite it first, and then we're going to do some cross-canceling. All right, so let's take a look at number 6. You see the single coke is back. So the single coke means that there's no plus or minus signs here, right? No plus or minus signs, so that means there's no groups, right? Which means that you don't have to factor. You can start slashing away. Well, not quite yet, right? Because what we're going to want to do is flip the second fraction and multiply. And I've got just as a little reminder here on the top right, just got a little reminder there for you. You also notice some negative exponents, so we're also going to have to turn some frowns upside down. So there's kind of a lot going on with this problem. So let's rewrite it first, and then we can get to slashing and all that kind of stuff. So just remember with this, copy dot flip. So again, the first fraction is going to stay the same. So I'd have 8x to the negative 2, y negative 3, over 12a negative 2, b negative 3, times, right, because this is the part we're changing, times, and then we're flipping it. So you'd have 3, a to the negative 4, b negative 1. And now again, keep in mind here, me flipping, this is because I'm changing division into multiplication. I'm not flipping because I'm turning any frowns upside down. So you notice that these negative exponents stayed the same. We'll turn some frowns upside down here in a second, but we just want to get it rewritten first, and then we can do that. All right, so now it's rewritten as a multiplication problem. I'm not going to start cross-canceling yet, again, because I need to rewrite this with positive exponents. So what I'm going to do with this, and I'll come over here with it, is, first of all, the numbers, we only rewrite negative exponents. So numbers stay the same. So for instance, 8, 12, those two things would stay the same. Now, you notice here, x negative 2, that would go to the bottom and become x positive 2. A negative 2 that's on the bottom, that's going to go to the top and become a positive 2. Y negative 3, go to the bottom, become y positive 3. B negative 3, get a little attitude adjustment there. Now he's happy, go to the top. Let's do the same for the second fraction. So a negative 4 would go to the bottom and become a positive 4. X negative 1 would go to the top and become x positive 1. B negative 1 to the bottom, b positive 1. Y negative 4 to the top to become y positive 4. All right, so now we've rewritten it as a multiplication problem. Check. Rewritten with positive exponents. We've turned everybody's frowns upside down. Check. Now we can start slashing away here. So let's see what we can cancel. And again, doesn't matter where you start. 3 goes into 12 4 times. Let's talk about some x's here. Take 1 away from x2. You got 1x left over. Again, it's always the smaller going into the larger. So when you're trying to think about which direction to go, take 3 away from 4. There would be 1 left over. Let's go the other direction with it. 4 into 8 2 times. Looking at some a's. If you took 2 a's away from a4, you'd have 2 left over. And finally, the b's. If you took away 1b from b cubed, what's left over would be b squared. And you want to be, fairly neat with how you're writing this, because it can get a little messy and it can be kind of hard to keep track of everything that you've written. Which again, that's one reason why we use a highlighter here to maybe highlight everything that's left over. And it looks like that's everything that's left. So what's on top there? I've got 2 b squared y. And on the bottom, we've got 4 a to the x. I'm sorry, not a to the x, a times x. Right? All right, so again, rewrite this with multiplication first, then turn the frowns upside down, then you can start slashing away. All right, so pause now and try number 6 in the middle. Actually, hold on real quick before you go on to number 6 in the middle. Just realized couldn't read my own handwriting here. When you took two a's away from a4, that would be a squared. I don't know, that didn't really come out very well, so let's fix that. That actually should be a squared. And then there's one other thing you might notice here is that 2 over 4, can you reduce 2 over 4? Yeah, sure, you could reduce 2 over 4. You can divide top and bottom by 2. So if you divided top and bottom by 2, or maybe another way to think of this, which would be 1/2, right? But another way to think of this is you could also say, well, 2 goes into 4 2 times, and then so there's not anything left over. So the fully reduced answer on that one would be b squared y over 2a squared x. So I kind of caught myself before we went on to the next one. So make sure you have that one. All right, so for real this time, pause the video, try number 6 on the right. I'm sorry, number 6 in the middle. All right, so let's see what you came up with. For number 6 in the middle, should have got 25y squared over 18a squared x. If you got it, great. Pause now and try number 6 on the right side. If you didn't get it right, then let's hold on here for the explanation. And again, when we go through this, if you catch a mistake, then go ahead and pause the video and try the rest of it on your own. So it's not going to do any good if you just copy everything down I write. You want to really be trying to do this on your own. Alright, so remember the first fraction stays the same. I'm not worried about changing any exponents at this point. So I'm not worried about changing any frowns upside down. So I'm going to rewrite this one. So everything that's on the bottom will now be on the top. Everything that was on the top will now be on the bottom. Alright, so I've rewritten it as multiplication problem. Now what I want to do is I want to turn frowns upside down. Actually make that a little shorter. So I want to turn some frowns upside down. Now the numbers, by the way, the numbers will stay the same, and we'll get to canceling the numbers in a second. You got 20 over 27. So I don't know, let's take a look at x negative 4, for instance, right? And maybe I'll color code this one so you could see that a little better. X negative 4, turn his frown upside down, becomes x positive 4. A negative 3, turn his frown upside down, becomes a positive 3. If we talked about y negative 2, turn his frown upside down, becomes y positive 2. B negative 2 becomes b positive 2. Right? So let's take a look at that second fraction then. So you got 15 over 8. Again, the number stays the same. And then let's talk about the a's. So that a negative 5 would become a positive 5. We'll keep it the same colors there. X negative 3 would become x positive 3. And b negative 2 would become b positive 2. And then y negative 4, do we miss a color here? Oh, our y's are green. Y negative 4 would become y positive 4. Okay, so I've rewritten this multiplication. I've turned everybody's frown upside down. Now I think we're good. Now I think we can start cross-canceling. So let's talk about the numbers. So 8 goes into 20. Well, no, actually it doesn't. But a number that does go into both of them is 4. So 8 divided by 4 is 2. 20 divided by 4 is 5. Look at the other way. 15 doesn't go into 27, but 3 goes into both of them. So 15 divided by 3 would be 5. 27 divided by 3 would be 9. And then let's talk about some letters here, some variables. Take 3 away from 4, so what you'd have left over just would be 1. If you took 3 away from 5, you'd have 2 a's left over. If you talked about b squared and b squared, they're actually the same, so they'd cancel each other out. And then y squared, if you took 2 y's away from y4, you'd have y squared left over. So let's take a look at everything that's left over. Looks like I got a 5 left over. Well, that's not a very good color. Let's try another one here. That might be worse. We're going to go with it. So 5 y squared, we got a 9x, and we got a 2a squared. So let's put all that together. We did turn our frown upside down, so we could say goodbye to you. So what's on top there is 5 times 5, which would be 25. So you got 25y squared over 18a squared x. All right. So go ahead and pause now and try number 6 on the right side. All right, let's check number 6 on the right side there. Should have got 2y over 3ax. So again, if you got it right, high five, pound it out, fist pump. If you didn't get it right, then, well, hold on and ask for some help. All right, otherwise, let's move on. So let's look at number 7. So we're still dividing, so we still are going to have to rewrite this as multiplication first. So that will be our first task. Again, we're going to do a little copy dot flip here. Copy dot flip. So copy, keep it the same. 4a plus 4c, 5a squared c cubed. Dot, right, so that means the division is going to turn into multiplication. And flip means we're going to take the reciprocal. So 10 is now on top. Negative 2a minus 2c is now on the bottom. Alright, so you notice the little single Coke, the little 20 ouncer is not there anymore. The 12 pack is back. Why is the 12 pack back? Because we're talking about groups. How do we know we're talking about groups? You see the plus or minus sign. Well, it's actually kind of a mix, though. Maybe we should have the 20-ounce bottle here as well. Because you say, well, like, I don't see a plus or minus sign there. Well, that is correct. So this is not a group. So this is actually something we could start cross-canceling. The plus or minus sign, that says that those guys got to be factored first. So let's do that. Let's factor those first, and then we can talk about the rest of that. Alright, let's see, what do they have in common? Well, they both have a 4 in common, so let's say we factored out a 4. And then you say, well, what's left over? Well, 4 times what would make 4a? Well, that would have to be a. And then 4 times what would make 4c? Well, that would have to be c. Now, again, the bottom is not a group, so it doesn't need to be factored, so I'm just going to rewrite that. Same thing for 10. Now, again, this is a group, because you see the plus or minus sign. That does need to be factored. So we say, well, what do they got in common? Well, they both have a -2 in common. So let's factor out a -2. And then if you said -2 times what would make -2a, that would be a. -2 times what would be -2c? That would have to be a positive c. And the reason why that's a positive c is -2 times positive c would be a -2c. And the other thing, too, that you want to keep in mind is that, you know, if this is an a plus c over here, then this is probably going to be an a plus c over here. Because that's the whole point of this, is we're trying to cancel stuff. We're trying to cancel groups, right? So you start looking for that. You start looking for things that kind of match up so you can cancel them. Well, now they are the same, so we can cancel. Now 5 and 10, 5 goes into 10 2 times. And let's see, -2. Now if you said -2 divided by -2, that cancels itself out. And 4 divided by -2 would be a -2. So notice that would be a -2 there. So when I look to see what's left over, I've got a -2 left over, a +2, and I've got this a squared c cubed left over on the bottom. Multiply across the top, you got -4 over a squared c cubed. Alright, so this one was kind of a mix. It was a mix of something that was a binomial, these two, that had to be factored, with things that were monomials, things that are don't have a plus or minus sign, so they're not a part of a group. Alright, I know you're anxious and you're ready to go ahead, so try number 7. We'll pause now and we'll see you in a second. Alright, so let's check out number 7. So number 7 in the middle should have got -36 over 5x to the 4th, y to the 5th. And actually, I should have mentioned something on this other one. I kind of overlooked it. You know, when a fraction's negative, it's not really that the top's negative, the bottom's negative. It's really that the whole fraction is negative. So, you know, how we could have rewritten this, let's get our Coke out of the way there. How we could have rewritten this really would be a negative out front, and then like that. So, you know, not a big deal, but a little formality as far as, you know, how you could expect that to be rewritten. So, you know, really what we should say there is we should put the negative out front like that. But you get the idea. I just want you to know how you can expect to see it on the test, is that they would put the negative out front. All right, so go ahead and pause now and try number 7 on the right side there. And actually, though, if you didn't get number 7 in the middle correct, then let's walk through that before you try number 7 on the right side. So again, we're going to rewrite, so 9x plus 9y over 5x to the 4th, y to the 5th. Division turns to multiplication. I'm going to flip. -3x minus 3y. And again, what we were doing there is we were doing our copy dot flip. And so let's see what we can do here. Now, so these are, again, these are groups, so they need to be factored first. So let's see what we can do about factoring those. What do they have in common? Well, it looks like this one, where they both have a 9 in common. So let's factor out a 9. what would be left over would be an x plus y. The bottom there, not a group, does not need to be factored. 12, not a group either, does not need to be factored. What do they have in common? Looks like they've both got negative 3's in common. And if you took away that negative 3, what would be left over would be x plus y. Now we're in the position to start canceling. X plus y and x plus y. If we look the other way, negative 3 divided, or 9 divided by negative 3 would make a negative 3. And then if I wanted to know, okay, well, what's all left over here? I've got a negative 3 left over, I've got a 12 left over, and then I got all this stuff right there. So negative 3 times 12, which would be a negative 36, over 5x to the 4th, y to the 5th. Alright, so now, if you hadn't already done so, pause and try number 7 on the right. Alright, so let's check it for you. Number 7 on the right side should have got negative 12 over g squared h to the 5th. Alright, so hang in there. We're almost there. Appreciate you hanging in there. Appreciate you being here, as I said, and taking a positive step towards help raising your grade. Let's take a look at number 8. Well, before we look at number 8, and actually 8, 9, and 10, this will kind of finish us out. So let's kind of recap. We've reduced these funky fractions, and again, a rational expression is just a fraction that has numbers, variables, and exponents in it. So we've reduced these funky fractions, we've multiplied them, we've divided these fractions. Now the last thing that we have not done is we need to look at how do you add these fractions. Well, before we look at how do you add a funky fraction like that, let's look at how do you even add a baby fraction. Well, so think about baby fractions, right? What you need is you need a common denominator. So what I cannot do is just start adding straight across here. You can multiply straight across, but you can't add straight across. Well, you need a common denominator. And so what you ask yourself is you say, well, what can I do to the smaller number to make it look like the larger number? So what could I do to 3 to make it look like a 9? Well, you could multiply by 3. But then what you do to 1, you have to do the other. So if we multiply the bottom by 3, you then also have to multiply the top by 3. So what you'd end up with there is 3 over 9 plus 2 over 9. Now that you have a common denominator, now you can add them up. So you add the top, keep the bottom, so you'd end up with 5 over 9. Now, what if you look at this one, for instance, you say, well, okay, what if I can't multiply 4 by anything to make it 5? Well, then what you have to do is you have to come up with a whole new number that they would both go into. Well, so you think about what 4 and 5 both go into. They both, if you think about the multiples of 4 and 5, right? So if I did the multiples of 4, 4, 8, so let me write it this way. If I said the multiples of 4, let's say 4, 8, 12, 16, 20. If I said the multiples of 5, 5, 10, 15, 20. Oh, okay. So the first number, the first multiple that they have in common would be 20. So what that means is that our common denominator would be 20. And then I have to go back and say, okay, what can I do to these two numbers to make that happen? Well, I'd have to multiply that one by 5. I'd have to multiply that one by 4. And then once you get common denominators, then you can add it up from there. So that's what you do with the baby fraction. So again, what you do with the baby fraction is really going to be the same thing that you do with this funky fraction. So the only difference here is that if you look at number 8, instead of just saying, 3 and 9, we've just thrown some x's and some y's in there. So that's the only difference there. You notice at the top right there, though, this question that I pose is, what can I do to make both denominators look the same? Because that's what we're really trying to figure out. Well, I don't know. Let's just start with the number, for instance. So if it was, let's pretend for a second that there was no, there was no x and y and all that stuff. You say, well, what could I do to 3 to make it look like a 9? Well, you'd have to multiply by 3. So you'd have to multiply by 3, and we'd have to do that to the top and the bottom. But let's also look at the other things as well. if I wanted this one to look like that one, well, this one has a y squared. This one only has a y, so that means that he's short a y, and he needs another y. So I'd have to multiply this one by y as well. And now I look at this one, I say, okay, was there anything on that the left fraction does not have that the one on the right does have? Well, the one on the right has an x, so if I want them to look the same, this guy would need an x. Again, we're just trying to get them all matchy-matchy, so they look the same. Now, when we multiply these out, when we multiply this out and we multiply that out, it should be the same. So that's how we would know that we did it correctly. So let's multiply the top. So x times 2x would give you 2x squared. Go back to my other marker here. 2x squared. On the bottom, you've got 9xy squared plus 5y times 3y would be 15y squared. And then 3 times 3 would be 9xy squared. Well, hey, look at that. The denominators match. So when the denominators match, then you can just add the two things together. Now, if I try to add x squareds and y squareds, those aren't like terms, so I actually cannot combine those. So don't try to say, 17x squared y squared or something like that. They're not like terms. So the best that you could do is just rewrite it. 2x squared plus 15y squared over 9xy squared. That would be as far as you can take it. You can't reduce this because there's not a number that goes into 2, 9, and 15, nor do they all have a letter in common, variable in common, so you wouldn't be able to reduce it from there. All right, so try number 8 in the middle. Hang in there. We're almost there. Go ahead and pause the video now. Let's see what you got for number 8 in the middle. Should have got 5x cubed plus y cubed over 4xy cubed. A lot of cubes there. All right, so if you got that one right, great. Go ahead and pause now. Try number 8 on the right side. If you didn't, let's kind of walk through that one together. And I'm thinking if you didn't get this one right, you probably had difficulties setting up that common denominator, because that's kind of the tricky part. So let's look at that part of it. So again, you're trying to figure out what can you do to make these two look the same, the two denominators. So I always kind of start, for some reason I always kind of lean towards looking at the smaller number, saying how can I make the smaller number look like the bigger number? So how can I make 4 look like an 8? Well, I could multiply it by 2. And then what I say is, okay, because 2 times 4 would be 8. And then let's see what else this one has. This one has an x over here. This guy doesn't have an x, so I'd also have to multiply by x. Now what I check to see is I see, okay, now is there anything that the left side has that the right side doesn't have? Well, if you look at the y's, the right side only has one y, and the left side has 3 of them. So if we wanted them to match, the one on the right needs 2 more of them, so we'd have to multiply by y squared. Then when you did that, 2x times 5x squared, that would give you 10x cubed. 2x times 4y cubed, well, 2 times 4 would be 8. 8xy cubed plus 2y cubed, and then 8xy cubed. And so again, the test to make sure that you did this correct is when you get to this point, your denominator should be the same, right? Because that's the whole point, trying to get a common denominator. So when you multiply it out and something's missing, like so let's say you got y squared here and y cubed there, well that means that you missed something. So you got to go back and make sure you got everybody accounted for. X cubes aren't the same thing as y cubes, so I cannot simplify that any further. So I would have 10x cubed plus 2y cubed over 8xy cubed. All right, go ahead and pause now and try number 8 on the right side. All right, so let's see what you got with number 8 on the right side over there. Should have got 2x to the 4th plus 12y to the 4th over 15xy to the 4th. Again, if you didn't get that one right and you need a little more help with it, don't be afraid to ask. Otherwise, we'll move on. Number 9. So hang in there, only 2 more to go. So we're still adding fractions. We know that fractions, we need common denominators to be able to add fractions. And we said, what can you do to both denominators to make them look the same? So what I'm saying is, what can I do to x plus 5 to make it look like x squared plus 3x minus 10? Well, notice the thing here is that this is a binomial, this is a trinomial. But we know that if you factor a trinomial, if you factor a group of 3, that it's really the product of two binomials. Meaning that what we would have to do is we'd have to factor this first to figure out what that would be factored. And then I'm thinking that probably one of these is going to be x plus 5. And then what we're looking for is what the other thing would be. Well, let's go to the side. We'll do a little scratch work over here. So two numbers that multiply to negative 10 that add up to a positive 3. 5 and 2, I've got more positives. That means the bigger number would be positive, smaller number negative. So I've got x plus 5 and x minus 2. So if I were to ask myself, well, what does the right side over here have that the left side doesn't have? Well, they both have x plus 5s. So if I said, well, what's this guy missing? He's missing an x minus 2. So then what I would have to do is multiply both sides by x minus 2. Now, if I multiplied x minus 2 times x plus 5, I already know what that is. It's x squared plus 3x minus 10. So there's no real surprise there. So what I can do is I can actually put those back together. Let me put my marker back. So on the bottom there, I've got x squared plus 3x minus 10 plus, get rid of this thing. Now the second fraction stayed the same, so I've got 6 over x squared plus 3x minus 10. I didn't do anything to that one. Now the only thing we need to figure out is that what's x minus 2 times x plus 3. So that's where we have to multiply those two things together. You can FOIL it out if you're a FOILer. Also, I've shown you the boxes is a way to multiply. So I would take one of the groups, x minus 2, take the other group, x plus 3, and I just would multiply it out, right? What's on the left times what's on top, x times x, which would be x squared, x times negative 2, which would be a negative 2x, x times 3, which would be a positive 3x, and then 3 times negative 2, which would be a negative 6. Let's combine our like terms, right? Because if we're talking about like terms, those numbers right there, those are our like terms. 3 minus 2 would be a positive 1x. So we could just write x, and then minus 6. Alright, so if I put that up there then, so I've got x squared, and put that here. So I've got x squared plus x minus 6. Now you're like, okay, so what do I do with that? How am I supposed to multiply those two things together? Well, what you would do with those two things, I'm going to move this out of the way. We'll just get rid of it. What you do with those two things is that you would, you put them together really as one big fraction. So let's do that, right? Because that's what you're kind of doing. You're taking these two fractions, putting them together as one fraction. So if I did that, I've got x squared plus x minus 6 plus 6. And then the denominator is the same. So if you look at it, you say, oh, okay, well 6 minus 6, those two things cancel out, and you say, well, what's left over? Well, what's left over would be x squared plus x over x squared plus 3x minus 10. Right. And you could actually factor out an x of both of those, right? So the alternative, that actually also could be rewritten as x times x plus 1 over x squared plus 3x minus 10. So that would be the other way you could write that. So either we'll put an or there, because you could actually express it either way. Alright, so pause now, try number 9 in the middle. Let's check out and see what you got with number 9 in the middle. Should have come up with x squared minus 23 over x squared minus x minus 20. And if you got that right, yay, good for you, high five. If you didn't, hang in there, and let's kind of go over that one, because these last couple ones, I should tell you, by the way, 8, 9, and 10, these last 3 problems, these are probably 3 of the tougher problems on the test. You know, for a lot of people, adding fractions is difficult as it is, much less adding funky fractions like this, right? If you did get it right, go ahead and pause now, try number 9 on the right. Otherwise, we'll talk through what to do on this one. So again, what we said is that we wanted to factor this thing to figure out what's missing. So you have to factor this first to find out what's missing. And again, if this is an x plus 4, I'm thinking one of these is going to be an x plus 4. So we're just going to do a little big X over here, a little scratch work. 2 numbers that multiply to negative 20 that add up to negative 1. Well, not 2 and 10. Oh, 5 and 4. And you have more negatives than positives. So negative 5 and a positive 4. So if we compare the two and we say, well, what does this one have? Where does this one doesn't have? I guess we could say. Well, they both have an x plus 4. What this one is missing is missing an x minus 5. So what I would need to do is I would need to multiply top and bottom by x minus 5. Let's multiply by x minus 5 and time x minus 5. Okay. All right, so if I multiplied on the top, x minus 5 times x plus 5, and again, if I wanted to, I could do a little scratch work on that. Go to the side here. I want to multiply x minus 5 times x plus 5. Again, what's on top? What's on the side? So x times x, which would give you x squared. X times negative 5, which would give you negative 5x. X times positive 5. Positive 5x, and positive 5 times negative 5, which would give you a negative 25. One thing you notice about this one is that actually your like terms there, those two things actually cancel each other out. So what you're left with is just x squared minus 25. So that's what actually is going to go on the top of our new fraction over here. So let's come back to it. So I've got x squared minus 25. That's what I just came up with. We'll go ahead and multiply these things back together. So the denominator would be x squared minus x minus 20. Plus, I've got 2 over, again, the same thing, x squared minus x minus 20. So similar to the last one, we said we're just going to put this together as one big fraction. So I've got x squared minus 25 plus 2 over x squared minus x minus 20. Well, my only like terms on this thing are those two numbers right there, negative 25 plus 2. So if I added those two things together, negative 25 plus 2, which would be negative 23. So I've got x squared minus 23 over x squared minus x minus 20. All right, very good. So go ahead and pause now and try number 9 on the right side. And then after that, we just have one left. Alrighty then. So let's check number 9 on the right side. Should have got x squared plus 4x plus 8 over x squared plus x minus 6. So again, if you got it right, yay. If you didn't get it right, well, there's a lot of enthusiasm there, huh? Yay! All right, we're really excited. But if you didn't get it right, that's okay. Try to figure it out on your own. And if you're not able to, then well, ask for some help. All right, number 10, last question here. And again, just kind of set this up. I just wanted to kind of remind you that a fraction is just another way to write a division problem. So think about like a baby fraction, like 10 divided by 2, for instance. 10 divided by 2, because that's what that bar means division. So that also could be written as 10 divided by 2, right? Could also be written that way, which of course would be 5. Now what you notice down here, now this is the funky of the funky of the funky fraction. This is actually super funky fraction, right? Because it's a fraction in a fraction. So at first it might look a little scary, but in the same way that we just unstacked it, see how we 10 and 2 were stacked, and then we unstacked them. So in the same way, we're just going to have to unstack it first, and then I promise you it's not going to be as bad as you might think. I've got a little diagram over here in the right corner just to show you. If, and again, this is just with a baby fraction. If you had 1/2 divided by 3/4, if you unstacked it, the numerator, the number on top, just goes first. So the 1/2 would come down here. And the number on the bottom, the denominator, that number would go second. So we're just unstacking it. So if you look at this thing over here, it looks a little crazy. So we just would have to unstack it first. So if I wanted to unstack that, again, the numerator is going to go first. So I would have 4y over, I got my arrow in the way, 4y over 11. And then the denominator is going to go second. Right? Now, what you have in the denominator, you actually have two fractions in the denominator. You actually have kind of two things happening there. Let me rewrite this. And we're saying divided by. And you actually have two things in the denominator there. So when we bring this thing over here, we've actually have two fractions there. We have y over 2 plus y over 6. Well, so let's think about what you'd have to do here first, though, is that before we start talking about dividing fractions, we have to combine these two fractions together first. So what it's almost like doing is saying we've got to kind of go down here to the side and do a little bit of scratch work, like y over 2 plus y over 6. Now this is hopefully a simple fraction. What two numbers multiply, or what number does 2 go into 6? Well, so that would be 2 goes into 6 3 times. So you'd multiply top and bottom by 3. And then so what you're left with is you've got 3y over 6 plus y over 6 equals 4y over 6. So what I can do with that is that I can then come back up over here. And by the way, I could have done, this side work that I did right here, this little scratch work, I could have done that right there before I even unstacked the fraction. So I could have done that as well. So maybe even before I wrote that, I'll just even erase it to show you what we could have set it up as. We could have said, okay, well the answer is 4y over 6. So I could have said 4y over 6. So that's a kind of another way to think of it. Now, so it's division. We know that division turns into multiplication. We do our copy dot flip. So we know that's really 4y over 11 times 6 over 4y. And then all we're doing there is we're just canceling. So we can cancel the 4y cancels with 4y. I don't have to factor because there's no groups. And then what's left over there would be 6 over 11. So it's something that started off with kind of a freaky looking fraction, but once we combined the two fractions on the bottom over here and then rewrote it, it wasn't too bad. Alright, so the finish line was within sight. Hang in there. Try number 10 in the middle, and then we're almost finished with this thing. Alright, so you should have paused the video by now. Should have done number 10 in the middle. So let's check your work, see what you came up with. Should have got 4 over 5 for number 10 in the middle. Should have got 4 over 5. If you got it right, final high five to you. And you can go on to number 10 on the right side. If you didn't get it right, then let's hang on and check out the explanation on that one. And again, I think what I might do on this one is, let's go ahead and do kind of the scratch work here on this. So we'll kind of figure out what this is going to be. So let's take x over 4 plus x over 2. And so we're just doing this before we unstack it. And so I want the denominators to be the same. So what can I do to 2 to make it a 4? I have to multiply by 2. And then so if I did that, I'd have the first fraction stays the same, x over 4. I'd have 2x over 4. And then so if I added x plus 2x, I'd get 3x. Not 2x squared, right? We're not multiplying, we're adding here. So if I had an x plus 2 more x's, now I've got a total of 3x. So I've got 3x over 4. Now again, that's not my final answer. That's just now what I can do is I can come back up over here and I can rewrite it. And I don't know, if you wanted to, you could rewrite it this way too. You could say 3x over 5 divided by 3x over 4. Right, because I simplified that first part of it. Now let's unstack it. So the first fraction, the numerator goes first. 3x over 5 divided by the second fraction, 3x over 4. And then once you get it as a division problem, then you can rewrite it, do your copy dot flip. I don't think we wrote that on the last one. Copy dot flip. So 3x over 3x over 5 times 4 over 3x. And then what you see is that the 3x's cancel each other out. And then what you're left with is just 4 over 5. So that's how we came up with an answer of 4 over 5. Alright, this is it. I know you're sad. This is the last problem for us. All good things have to come to an end, I suppose. So try number 10 on the right, see what you come up with. Alright, we have found ourselves at the end. Number 10 should have got 8 over 15. If you got that one, you're ready to take the test. Hopefully you're feeling a lot better about it. If you didn't get that one, try to figure it out. If not, ask for some help. Either way, I really appreciate you coming to tutoring today. Appreciate you sitting through this video and putting in some good work and effort, because I can see you right now. I can see that you've done some good work. You may not know it, but I can magically see through the screen and see that you did some good work. So proud of you for being here, proud of you for putting in the time. I know coming in after school on your own time maybe isn't your first idea of what you'd want to do with your afternoon, but hopefully it'll feel good and it'll be worth it when you see your grade going up. So we'll say goodbye at this point. And so now that you're done with the study guide, go ahead and turn it in, and let's retake the test. All right, so thanks again, and we'll see you next time.